Good day, everyone. My name is Festus Olutoge from the University of the West Indies, Trinidad and Tobago. I am here to present my paper titled Structural Strength Potentials of Nigerian Groundnut Husk Ash as Partial Cement Replacement in Mortar. I will follow established protocols by starting from the introduction through methodology, results, discussion, and conclusion. Introduction. Majority of structures worldwide are composed of cement, aggregates, and water. Sustainability and cost issues and problems have, however, led into the search for alternative binders. Industrial and agricultural wastes. Industrial and agricultural wastes such as granulated blast furnace slag, fly ash, rice husk ash, corn cob ash, palm kernel ash, etc. have been studied and have performed as pozzolans in cement-based composites. Groundnut is a common cash crop found in West Africa and other tropical areas of the world. And the husk is a waste material after milling of the groundnut. The husk comprises about 25% of the total hard husk and seeds. And about 58 tons of groundnut husks are produced annually in the world. Objectives. The major objectives include determination of chemical content of groundnut husk ash, preliminary tests on GHA paste, fine aggregate, and fresh mortar produced. Determination of strength properties, compressive and flexural only of mortar, incorporating groundnut husk ash. And finally, development of predictive models using artificial neural networks. Methodology. Experimental procedures adopted in the study include conversion of groundnut husks to ash, preliminary tests on the ash and aggregates, production of mortar cubes containing groundnut husk ash as partial replacement at 0, 5, 10, 15, and 20% replacement levels. Prisms 100 by 100 by 400 were produced for flexural tests. Compressive and flexural testing of cubes and prisms cured for 7, 14, 28, 56, and 90 days in accordance with standard civil engineering procedures. The materials used. Groundnut husk ash. The groundnut husk is shown in the figure, the upper figure there, and then the lower figure is the cement that was used. And then you have sand and also water. And the blending ratios have been shown on the screen. Mixed design and constituents. Constituents for mortar productions are also shown in the table. Here, materials are shown in kilograms, water in liters, and the water binder ratio is kept constant at 0.5. Manual blend of cement and groundnut husk ash is referred to as the binder, and the ratio of 1 to 3 of binder to sand ratio was used. Compaction in molds of mortar were in 3 layers, and specimens were cured, as previously mentioned, for 7, 14, 28, 56, and 90 days based on testing ages. Testing. Tests conducted on fresh mortar are consistency and setting time tests. Tests on adding mortar were compressive strength, flexural strength, and pozzolanic index tests. The tests were performed in accordance with standard codes of practice. Statistical tools were used in analyzing the results obtained from the laboratory, while the artificial neural network model was applied in predicting the compressive strength of the mortars. Results. The first result shown there is the chemical composition and the comparison of the chemical requirements and groundnut husk ash pozzolanic composition. So according to classifications, we can see that the class of groundnut husk ash is out of the recommended classes of N, F, and C by ASTM. Its own value is not up to 50 or 70. Is the summation of required constituents are 26.98. Consistency tests. Consistent test results for various replacement levels are also shown. Penetration of the plunger from the top of the picot mold is 35 millimeter, and the time of mixing is 4 minutes. Setting time. The result is shown in the figure. Results suggest that groundnut husk ash retards the setting times of cement, which implies more delay in setting times. Blended mortar will be useful in hot climates and over long haulage of ready-mix mortar concrete. Compressive strength. Effect of compressive strength is shown in the figure. There is increase in compressive strength with age, and this is due to continuous curing and progression of the hydration process. And then the next one is the flexural strength. Effect of flexural strength is shown. Flexural strength was investigated at 2 curing ages, 28 days and 90 days. The values are somewhat low compared to corresponding compressive strengths at the same ages. Binder containing groundnut husk ash may not be suitable where flexural strength is a critical factor. Then pozzolanic activity index. The result is shown on the table. The values are above the 75% minimum value specified by ASTM 618 of 1994 for utilization of a pozzolan. Then the artificial neural network. Again, the result is also shown on the table, and the figures show that the graphs of comparison of target and testing results shows that the model is accurate as the results are precise with minimum error. Now we come to the conclusion. And then the conclusion are shown. Some of silicon oxide, iron oxide, alumina, and other oxides for pozzolan reaction is 26.98. Water requirement in the paste increases as level of replacement for Portland cement with groundnut husk ash increases. The compressive strength of the mortars increase as replacement increased from 0 to 10. But after 10%, it continued to decrease. And the pozzolanic activity index values at the 3 ages investigated are above 75% of the minimum value specified by ASTM 618 for utilization of a pozzolan. So it can be safely used as a partial cement replacement. And the proposed artificial neural network model is good to be used as a predictive model for compressive strength of the mortar. And from the results above, to be good if the results are used on field for prediction, even when data different are used. And then the references used. Thank you. So I come to the end of the presentation.
Thank you, Zach, for a wonderful presentation. Do we have anyone to ask any questions or anything to be asked commonly? Well, Zach, just want to know, like, nice to know that you have used artificial intelligence and the test results matching in your presentation. Nice to see that you are working on artificial intelligence technique on it. So, what would be a casual question? What would be the significance or a practical importance of your research for the community? Can you just summarize it on it? Like what is the social importance of significance of your project for your of your presentation of your research? How will it
Yeah,
be useful to the society?
okay, thank you very much. We all know that the present world we are in, we are having serious problems with the how do I put it, the greenhouse gases. And we know that cement production contributes about 7% to the greenhouse effect, to the carbon footprint. So what we are trying to do in this case is trying to achieve sustainable construction by reducing the amount of cement that we are going to use in construction. So, and this has been, such studies have been carried out for concrete, a lot, but little study has been carried out on mortar. You know, mortar is different from concrete. Mortar, we use mortar when we are placing our bricks or blocks. So, as opposed to the real cement. So, we're now thinking that if we reduce the quantity of cement in mortar, then two things: costs. We have saved costs. We know cement is very expensive. And then, secondly, we are also achieving sustainable construction, so that at the end of the day, we leave the world in a better place than we met it. So those are the practical benefits of the study. Thank you.
Thank you to know such a wonderful work with respect to the environment which you have done. Thank you for your wonderful presentation, Zach. So we'll just go ahead with the next presentation.